Here's problem number 38 from section 9.2 of our calculus book. It asks the question, is the third derivative of this function, defined by this Taylor series, equal to negative 1/3? Well, here's two different ways to attack this problem. Way number one, if f is equal to x minus x cubed over 3 plus x to the 5th over 5 minus dot dot dot. If I took the first derivative of this equation, I'm going to get a 1 here. I'm going to get a negative 2/3 there squared. I'm going to get a 5x to the 4th over 5 there plus dot dot dot. Well, what if I take the second derivative? Well, the constant term is going to go away. This term is going to turn into negative 4x over 3. This term is going to turn into 20x cubed over 5 plus dot dot dot. And then the third derivative of x is going to be the derivative of the first term, which is negative 4/3. The derivative could be 60x squared over 5, and so forth. And so when I plug in 0 for all these terms, all of these terms from here on, they all turn into zeros. So I get negative 4/3 is the derivative, the third derivative of this function at 0. So it doesn't seem to be equal to negative 1/3. So this answer is false. Now, that's sort of a long, drawn-out way of doing that problem. Another way of doing this problem is a little bit more simple. And it basically says that the third coefficient of the Taylor series is equal to the third derivative at your center divided by 3 factorial. If that's the case, and we can clearly see that the third coefficient, the coefficient on the cubed term, is negative 1/3, then we can solve for the third derivative, and the value of 3 factorial is 3 times 2 times 1. Well, something's wrong here, because when I bring that up, I get oh, I see where I made my mistake. Okay, so if I bring this up, I get 3 times 2 times 1 over 3. 3's cancel, and I get negative 2 is equal to f triple prime of 0. Now, over here, I can see I made a mistake now. I brought this power, at this point here, I brought the power down. That should be a cubed, and those 3's cancel. When I bring this down, that's a 2, and then when there, I get just negative 2 there. So I'm sorry I made that arithmetic mistake, but the third derivative at this location is clearly 2, negative 2, and negative 2 still doesn't equal negative 1/3.